In this demonstration, we will configure Colossal-AI to enable hybrid parallelism for distributed training. Let's go to the hybrid parallel folder. Inside this folder, there are two files used for training. The first one is config.py and the second one is train.py. We define all the training hyperparameters in config.py. Besides, we also configure Colossal-AI to enable hybrid parallelism here as well. In config.py, we can define our training hyperparameters here, such as batch size and learning rate. Besides, we can also configure the model parallelism here, including tensor parallelism and pipeline parallelism. As shown in line 24, we configure Colossal-AI to use 1D tensor parallel and pipeline parallel training. Now, let's take a look at train.py. To use hybrid parallelism, we have to import models from our own model zoom called Titans, as shown in line 4. In this example, we will build a vision transformer model, in short, VIT, to play around with hybrid parallelism, and use synthetic datasets to simulate the training process. And now we are ready to proceed to training. Let's first install the dependencies defined in the requirements.txt file. Afterwards, we use Colossal-AI run to launch multiple processes for distributed training with 1D tensor parallelism. As defined in the config.py file, we will run distributed training with tensor parallel size 2 and a pipeline parallel size 2. Since mproc per node is equal to 4, that means we are using 4 GPUs for training. Therefore, the degree of data parallelism is only 1. As shown by the progress bar, the training has started. Since this is a demo, we will only run for 20 steps and it's done. We can take a look back at the configuration. This just double confirms that we are running with tensor parallel size 2 and a pipeline parallel size 2. Now, we can play around with the config.py file to change the parallelism configurations. Let's change the tensor parallel size to 4 and change the mode to 2D. This will use 2D tensor parallelism for distributed training. As 2D tensor parallelism requires the tensor parallel size to be a square number, we need to set the mproc per node to be 8, so that tensor parallel size 4 times pipeline parallel size 2 is equal to 8, so that we have 8 GPUs to be fully used. Now we can see the same progress bar to show the progress of 20 steps of training. This video demonstrates how we can configure hybrid parallelism easily with Colossal-AI to train a vision transformer model on synthetic dataset.